Good day. Today, we will talk about systems planning and development. For today's presenter, we have Micah Boyno, June Ligan Jr., Dave Infante, Christian Gailan, and Zedric Abadides. Management Information System Planning, or MIS planning. According to a famous US scientist and inventor, Benjamin Franklin, if you fail to plan, you're planning to fail. That's why planning is a very important part in an organization because it is the main determining factor of a successful project implementation. Now, what is MIS planning? MIS planning is a planning activity that practically encompasses all operations of the organization immediately or remotely affecting information flow. Please remember that information system is the collection, storage, packaging, and distribution of data and information in an organization. Likewise, membership information system is an information system applied to management functions such as decision making and communication in order to help management create informed decisions with calculated risk based on the available data and information gathered and analyzed. Now, there are two phases of MIS planning. First is the MIS strategic planning, which is long-term, and the MIS operational planning, which is yearly planning of activities. Now, I will walk you through the MIS strategic planning steps. First, resolve basic planning issues. Second, evaluate the current IS or information system. Third, identify the constraints of the planning process. Fourth, identify the planning objectives. And fifth, compile an MIS strategic plan. To give you a better idea of what is MIS strategic planning, let's take this hypothetical organization, ABC Cooperative. Following the planning steps, ABC Cooperative, based on the first step, decided to take a 2-year planning horizon. And then ABC Cooperative evaluate its current information system, which is the information or membership information is only available at its physical office. The usual feedback of members are the long queue and waiting time. And many of its competitors, cooperatives, are already bringing their transactions online. Without availing this new trend, this ABC Cooperative would not be competent enough. Third is to identify the constraints to the planning process. So ABC Cooperative identified that the company has only one in-house programmer, that most of its employees are under early 50s and with steep learning curve, especially with regards to computers. And as far as sourcing of fund is concerned, there's a high interest rate of borrowing money from the bank because of inflation. And there's a delayed collection of receivables from members to fund the project, which is due to the pandemic. That's why ABC has difficulty raising funds. Fourth one is to identify the planning objective. Based on the 3 steps, ABC Cooperative decided to develop a mobile app and web app to serve more members and shorten waiting time. And the last but not the least is to compile an MIS strategic plan. Now, for the MIS operational planning steps, we have to identify the projects, identify an optimum mix of projects or activities, prioritize tasks, allocate resources and schedule the projects, and compile an MIS operational plan. As an example, ABC Cooperative identified the involved projects, which are hiring a programmer, getting a service provider, hardware and software upgrade, fund sourcing, and training of users. Now, based on these projects, we have to determine an optimum mix. So ABC Cooperative decided to get a service provider instead of hiring a programmer because it is cost effective. And to raise funds, it has to replace and sell old computers, liquidate non-performing assets, and increase members' capitalization to source funds to fund the project. Now, based on the mix of projects, the company has to prioritize. So its first priority is to raise funds. That's why it has to replace first and sell its computers, liquidate its assets, and increase capitalization. The second priority is to get a service provider. And the third and fourth priority follow. Fourth is to allocate resources to schedule the project. That's why in this part, we have to have our action plan and budget plan. And as an example, the first activity is to develop mobile app, which has a time frame of January 2023 to June 2023 with a project or a budget of 300,000 pesos. And in connection to this action, there has to be a calendar of activities or Gantt chart to monitor the progress of the action or the activity. And last but not the least is to compile an MIS operational plan. That's it. So mostly in MIS planning, the usual product or concern of this is the development of a computer-based information system. That's why our next topic will be systems development and management, which will be discussed by Dave. Dave?
All right, thanks, Jun, for that remarkable insights. So now let's proceed with system development and management. So when we hear about development, majority would think that this only involves programming. But then again, there's a lot of processes and phases that needs to be considered. So here comes the SDLC lifecycle. So this is a systematic approach in building and delivering software product in order to meet customer requirements. Moreover, it guides the stakeholders to ensure that the software development projects are completed within the time budget and we consider the quality of it as well. So think of it as a roadmap. That's why we have that picture. Wherein it guides all of the involved stakeholders. When I mean by stakeholders, not only the programmers are involved here, but also with the project manager and also the clients. So this is a collaboration. So in the SDLC, we have system lifecycle stages. So one of which is the conception stage, or as we call requirements analysis. So here we try to establish the question, what are the business requirements, how the project would come up, and we try to establish its objectives. So once we have established the objectives, we go to the design or development stage. So when we say development stage, we are now formulating how we can establish the solution based on the agreed requirements. So we're not dealing with the programming stuff here. Rather, we are just identifying and refining how the solution can meet the requirements. Next is the implementation or the coding part. This is also the birth stage, wherein we do the actual implementation or the coding part. And once we have completed the coding part, we go to the testing and deployment. So here we thoroughly test the quality of the deliverable. And once those were approved and marks the acceptance criteria, we can now deploy it to the production stage so that it can be readily available for the end users. And lastly, there's the maintenance and audit, wherein we continuously monitor, we do bug fixing, and if there would be some changes in the requirements, we do an update. And we can do the requirements all over again if it's required. But somehow, for some projects, maintenance and audit would stop. So when we combine all of these approaches, we can have different system development approaches. So one of which is the specification approach, wherein we do a analysis, design, implementation. You can think of it as a waterfall model. And the another one is a prototyping approach, wherein we incorporate the use of prototype. When you say prototype, this is a scaled-down version of the system to represent the proposed system to be developed in order to give the stakeholders a clear idea what is to be created. So we can further define the solution. There are other models that we know, such as the Agile and the iterative model and such. This will solve the current budget constraints and also how fast the project would to be implemented. So let's talk about in-house and proprietary software. So we know that in-house and proprietary have a lot of pros and cons, but here most of the proprietary software has the advantage when it comes to the cost, time, quality, and security. Whereas for in-house, this is more of a cost to meet for the business suitable for their needs. So these are the advantages as we research. So now let's proceed with the systems feasibility and assessment. So Christian will talk about.
Okay. Yeah. Thanks, Dave. So I'm Christian. So I'll be discussing systems feasibility assessment. So what's a system feasibility assessment? So system feasibility assessment is a comprehensive study that evaluates the considerations when approving a project proposal. So it's also an analysis of the viability of a project. So it's a study that helps project managers and stakeholders foresee the outcome of a project. Basically, it helps estimate costs, resources, and schedule the project plan so that it will be successful. Yep. So it includes areas of feasibility such as technological, economic, and legal areas. So why is it important? So in any project, there will be risks involved. So in a research conducted by the Standish Group from 2011 to 2015, more than half of IT projects went beyond their allocated budget and then were delivered beyond schedule. So before investing on any IS project, the advantages must outweigh the risks involved. Going to the technological feasibility, so it refers to the organization's capacity to develop, implement, and maintain a project. So there are important factors to consider when checking for technological feasibility. The first is the project size. So is the number of team members, schedule, and effort required enough for a project to be completed and successfully delivered? Next is the project structure. It entails how the project requirements are laid out and how well defined the team member structure and schedule is formulated. Next is the expertise and technology. The more familiar the project team members are with the technology and the domain, it means lower project risks. Next, we're going to discuss economic feasibility. So it involves the cost and benefit analysis. As a general rule, benefits should always outweigh the costs. So for costs, it can be one-time or recurring. One of them is the cost of developing and implementing an information system. So during the project start, we can have a one-time cost, and then in the succeeding phases, there can be maintenance costs which are recurring. Next is benefits. It can be tangible or intangible. One of example of intangible is the improvement in the morale of the employees due to improved processes. And for the tangible, those are the factors that can be measured. For example, that the amount of money saved because we cut down the process from 1 hour to 30 minutes. So the source is from a modern system analysis and design by Valasic and George. So these are one like a tabular example of benefits and costs. The final area of or the factor of when doing a feasibility study is the legal feasibility. So it's important to check the legal or contractual ramifications when conducting feasibility study. It involves such as copyright, labor laws, and foreign trade regulations. So a classic example will be the use of copyrighted software when building a project. So we need prior approval from the vendor or any third party involved when doing this.
Thanks for that, Christian. So much like planning and feasibility assessment are essential, managing a system development project is a crucial part of the process. When undertaking a systems development project, a systems development team must be put together. To manage this, let's first understand what a project team looks like. A project team comprises of system analysts, designers, programmers, and end users. A project lead is appointed among the team members to supervise and help ensure that the project development is on track. Additionally, a team librarian is assigned to produce the project documentation, which includes capturing project management constraints, such as these four below. For instance, if the scope changes, the quality of the project's output may be compromised if the initial time and resources allotted are not deliberately reconsidered. This includes the assessment of different tools and technology in order for the team to meet the project's evolving demands. A methodology tool aids in making sure that despite some changes in scope, the project team is well aware of the roadmap and individual assigned tasks. This tool is carefully selected to align with the project software development methodology. Back then, designing teams or designing systems involved a lot of paper handwriting. Nowadays, one can easily find online design tools to craft the system architecture efficiently, which often is online, so collaboration is now more convenient. Prototyping tools have become much more efficient, resulting in faster feedback loops. Additionally, librarians in system development teams can use information repository tools that are commercially available to make their documentation easily accessible. A fundamental piece of information such as data dictionary can be stored automatically using a catalog service, allowing the systems development team to retrieve the information at any time. Another efficient productivity tool is called Program Development Tool, one of which is a structured chart generator capable of creating visualized representation of the information system, such as the system's underlying process transitions and dependencies. Code generators that can automatically render a skeletal code structure make it more convenient for programmers to implement consistent architectural patterns and allow them to concentrate on other crucial aspects of the code. The use of pre-programmed processors has also become more common these days, which automatically identify program flaws and help uncover bugs early on, including security vulnerabilities before deploying to production. Finally, test data generators help programmers employ automated tests using a test data factory without having to pre-program the test data manually. So we've covered computer-aided software engineering tools so far. There are much more others, such as application development tools that cater to both developers and non-developers for creating applications, personal computer tools for day-to-day productivity, query languages for querying data, while graphic generators for data visualization, and lastly, application generators, commonly utilized for no-code development. As helpful and convenient these tools are, all of this comes with operational costs. So given that more tools are being introduced these days, project teams must carefully assess which tool is more appropriate for the project needs. The tools that we discussed cater to the project's end-to-end operation, that when program developers spend time building themselves, can divert their time and focus out of the actual project scope. Leveraging these tools offloads the typical operational overhead and keeps the system development teams focused on the critical aspects of the project itself, while not having to worry about the rest. Which brings us to the next topic, which is systems implementation. So over to you, Cedric.
Thank you, Micah. For our last topic is system implementation. As we move forward with this new project, it is important that we provide a seamless and efficient support for our users. The implementation of a new system can often bring challenges and difficulties, but with the right support plan in place, we can assure that our users are able to fully utilize the system to its full potential. For example, there are 5 components for a user support. Documentation, a detailed documentation on how to use the system, or it is a step-by-step instruction of the software or system. Next one is help desk, to assist users with any technical difficulties they may encounter, or the next one is a on-site support. For a larger organization, on-site support is to ensure that any issues are resolved as quickly as possible. This will include also training sessions for users and administrators, as well as regular check-ins to ensure that everything is running smoothly. Next one is user feedback. Gather regular feedback from users to understand any pain points they may be experiencing and use this information to continuously improve the user support. And lastly also is continuous improvement. Review and update the support processes to ensure they are effective and efficient. System testing focuses on verifying the end-to-end behavior of a system. System testing is a crucial step in a software development process, aimed at verifying the overall behavior and functionality of a system. The primary objective of system testing is to ensure that the system meets the specified requirements as function as intended in a real-world environment. So the goal is to ensure that the system function as intended in the real environment and meets also the specified requirements. Next one is the systems acceptance. The process of system acceptance can involve several stages, including functional testing, performance testing, and user acceptance testing. These stages help to identify any defects or issues in the system and ensures that it meets the necessary standards and quality criteria before it is delivered to an end user. Last is post-implementation audit. A post-implementation audit is an evaluation performed on a computer system or a software application after it has been put into a production. Its purpose is to assess the actual benefits realized from the system and determine its overall performance. That's all. Thank you.